What are muscle fibers made up of? Well, they're made up of sections called sarcomeres. The sarcomere has many different parts, starting with the thick filaments, which are made up of the protein myosin and have many myosin heads, as you can see here. The thick filaments meet at the M line and are layered in between thin filaments made up of the protein actin. Troponin is attached to the actin filaments and controls the protein tropomyosin, which protects the actin-myosin bonding sites. Finally, the thin filaments are attached at the Z line, which marks the borders of each sarcomere. Our next question is, how does calcium play a role in muscle contraction? When prompted by a neural impulse, the sarcoplasmic reticulum of muscle cells releases calcium ions, Ca2+, into the cytoplasm of the muscle fiber. Then what? Well, our calcium finds our thin filament protein actin and binds with the troponin. Well, what happens next? Let's zoom in on our actin and our myosin. When calcium binds with protein troponin, the troponin moves the tropomyosin out of the way, and binding sites are unveiled. Myosin heads then bind with the actin, and with a little help from ATP, a myosin head performs a power stroke, which will be explained more later. How does ATP play a role? The first step ATP plays is attaching to the myosin head, which keeps the myosin away from the actin. The second step is where ATP is split into ADP and phosphate. The phosphate transfers energy to the myosin head, putting it into the cocked position. Next, the phosphate releases from the myosin head and a cross bridge is formed, in which the myosin head binds to the actin protein. Finally, ADP releases from the myosin head, which performs its power stroke to shift the actin filament and contract the muscle.